Hello and welcome to the lecture series on the subject of object technologies and programming in Java, brought to you by St. Andrews Institute of Technology and Management. My name is Ravinder. I am an assistant professor with the department ETCE, and in the chain of discussions today we are going to discuss about a very important topic called exceptions. So let's start. Now, as the name suggests, exceptions are unwanted forthcomings. Again, I will repeat that. Exceptions are unwanted forthcomings which we do not expect to encounter, but unless until they are there, so we have to deal with them. Now, whenever there are some exceptions, the Java has an automatic way of dealing with them. Now, Java has Java virtual machine, and if an exception occurs or encountered by it, the Java virtual machine will try to handle it. Now, how it will handle it? Java virtual machine will have an object of the type of the exception, and that object will be displayed, and then and there the execution of the application will be terminated. Okay, so let's go back to the notes for some while. So Java exceptions can focus on the first line. When a program causes an error, Java throws an exception, and when Java then throws this exception, it will be caught by the Java runtime environment. Now, if you don't catch that particular exception manually or by hard coding it, the Java runtime environment will stop the termination of the application then and there, and that is not advisable because it is not expected, or it sometimes the unknown outcomings or encounters cannot be seen, or sometimes and few of the outcomes cannot be seen in advance or cannot be imagined in advance. So there is always a possibility that something out of the blue may happen, or the Java runtime environment may encounter it. So it is advisable to use exceptions in our code to deal with such type of eventualities. So let me give you a brief example on what kind of exception we are talking about. Say, and we will also hard code this particular example. Say we have an array named as ARR1, and let's say it has 5 elements. Say 1, 2, 3, 4, 5. Okay, so don't go into the syntax. I'm not trying to make you people understand what is the syntax, but I am just wanted to make you people understand what kind of exception I'm talking about only. So please focus on the exception only and not on the other things. We will try to write the exact code, the valid code in the IDE later on. So please don't focus on the syntax right now, but on the idea right now. Okay, so now if I try to assign some new value to a particular index, say ARR1, and say index second is equal to, let's say, 10, then that is valid, because now this particular index second, which contains the element this, has been replaced by a new value called 10. But what if I try to do something like, let's say, now what will happen? As we know that the length of this particular data structure is only 5 points, 5 data points, and when we try to change the value that is not in the purview of this particular data structure, it will definitely confuse the Java runtime environment, because here we're trying to change, or trying to assign a new value to this particular data structure at the index point of 10th, that is the 11th data point. Now 11th data point, as you have defined earlier, do not exist, that is not being declared by you. So the Java runtime environment will be confused. How could it be possible? Because earlier you have defined only 5 data points, so it has kept aside the calculated memory locations according to your declaration for this particular data structure. But then again, you are trying to do something which is not being told to Java runtime environment before, so it will get confused, and now it will throw an exception, and by that exception it means it will tell you back, okay, you're trying to do something like this, and this is actually not a usual thing. Okay, so you'll see a complete message to your console. Now if you are seeing a message out to your console, that is not a problem right now, because we can always minimize our console and our application will go on as usual. But that is not the way it is. The actual problem is, whenever Java runtime environment try to catch or throws an exception, it will also side by side terminate the execution then and there at that particular line of code on which it has caught an exception. So your application will terminate prematurely without reaching to final conclusion. Okay, so that is the main problem with the exception handling automation provided by the Java. It is solid, but it actually terminates your application, which is not advisable and which you do not want, because unforeseen circumstances do occur in our real life, but we try to solve it and kept moving on. We do not stall ourselves then and there if we encounter an exception in our daily life also. So we will do just that in Java by using the exceptions. We'll try to handle these unforeseen circumstances and try to evade them by using exceptions, or try to rectify those problems by using the exceptions, and we'll make sure that all of these unforeseen circumstances, that is called exceptions, must be caught, and that the premature termination of our application must not take place. Okay, so let's first talk a little bit about the exception classes. Now exceptions, all the type of exceptions, a few of them is that one just you have just seen is called array out of bound exception. It is telling you that this particular array which you are trying to do something to it is actually the index that you have provided is actually out of bounds. The initial bound that you have put in on this particular data structure is there, but now you have crossed that particular limit. So this is one example of an exception. These are predefined exceptions in your Java runtime. Once you get familiar with the exceptions, you will remember most of them, most of the commonly encountered. Other one is divide by zero exception, which you have seen in your mathematics also, because if you try to divide something by zero, it will end up in infinite value, and those infinite values are not defined to your system. So that is one type of exception. So these are the few exceptions I can name right now. There are many other. So where do all of these exceptions hold in the hierarchy of the classes? So the super class of all the exceptions is called throwable. Let me caps it again. So throwable class actually holds all the exceptions. And now it has two subclasses which obviously extends throwable. One is error and second one is exception. Now let me talk a little bit about this one first. Now this class, which is a subclass of the parent class of exceptions called throwable class, all the exceptions or the type of unforeseen circumstances that are being caught by this particular class are actually generated by the Java virtual machine, or actually generated in the Java virtual machine, which are not in your control because these are not generated by your code. Let me tell you that again. These exceptions which are caught by the error subclass are generated in the Java virtual machine and are not in your control because these are not generated by your code. So you cannot do anything about them. So we are not going to discuss anything about them right here in this particular lecture. The second subclass is exception subclass. Now this is of our importance. This is the prime focus in this particular lecture and coming few lectures. Now exception class holds all the type of eventualities that are being generated, that are being encountered while compiling or while running our code which has been written by us. Okay. Now this exception class has a subclass called runtime exception. A subclass called runtime exception. And this runtime exception class, which is a subclass of exception class, is actually holds all the common types of exceptions, a few of which I have discussed just a few minutes ago, like array of the out of bounds and divide by 0. Now these kind of exceptions you can handle by yourself using the exceptions block which we are going to discuss right about now. Now how to handle that? First let me again discuss a line which is important. How an exception is generated. So whenever an unforeseen event occurs while compiling our code, an object of a particular class of a particular subclass of throwable class, let me again iterate that, object of one of the subclasses of the throwable class is being generated. So there are only two subclasses of throwable, either error or either exception. So an object of one of these classes will be generated and it will be thrown out. And if you have written a code to catch that particular object, you can do something about it. And if you haven't written anything in your code to catch that particular object, the Java runtime environment will catch it and will terminate the execution and display that particular object. In that particular object, what you will see is the stack trace. Let me write that word, stack trace. So it will show you event wise what has been gone wrong, where is actually the eventuality, the unforeseen circumstances have actually occurred, and that all has been divided in set of events, and you can actually look through all those events and you can pinpoint from where it has started actually. So that is called stack trace. Okay. Now let's say how to do exception handling. Now, as I have told you before in this particular lecture, that handling the exceptions by the Java runtime environment is robust, but actually not advisable because it will terminate the application. So how you can handle it manually so that termination of the application doesn't occur, and you can try to undo the things that has been done by the exception, or you try to rectify the problem that has been encountered by the eventuality called exception. Okay? And that all of that goes into the topic called exception handling. Now in exception handling, the two main keywords are, or the main topic is try, catch, block. Now try, catch, block is the code which is going to catch the object of the exception that has been encountered by your code. Maybe it is there, maybe it is not, but if there is an exception that is being generated out of your code, so try block will the try block will try to monitor. It will monitor your code. If it throws or some exception is there, it will throw that particular exception object, and the catch block, which is following the try block, will catch that particular object and do something about it. So it will look something like this. We'll have a try block, and in this particular try block you will write something, some Java valid code, and if this particular code generates an exception, that is an object of a particular type of exception, this try block will throw that object out of this particular block. And after this try block, immediately you will have a catch block, which will have an argument and a catch block body. Now here the argument will be the object which has been thrown out from the try block, so it will be passed on here in the place of argument. And after that, when this catch block caught that particular object, we'll do something about it in this catch body here. We'll do something about it. We'll write some code, maybe try to undo some things, or we'll ask user to input something else which doesn't throw an exception, or just try to print a message, and that is it. So this is how it will happen. So let's try to do this particular thing. Wait a second. Let's try to do a small example of exception handling. I have created a class with main function in it, and we have discussed an example. We'll try to implement that one. I will create an array of type int, and let me name it arr1, or say xx1. Okay, and new, and let's say and let's say 5. Okay, so I've created an array of type integer which holds 5 data point locations. Okay, so its length is of 5, so you can imagine its first index will be 0 and last index will be 4. Now what I'll do is I will try to put something like x is 1 and let's say 6 and equal to let's say 10. Okay, and it means system dot out dot println, and if after, okay, and before that we'll also write something like system dot out dot println, and I'll write here before. Now I have told you, if we do not catch an exception, Java runtime environment will caught it for certain, and it will terminate the execution of the application then and there. And that is its shortcoming actually. So we'll see here before us that does it actually happen or not. If it doesn't happen, okay, then this after should print. That means if the termination doesn't happen, then this after should print. And if the termination is done by the Java virtual machine, this will not print. So we'll try to run this. Okay, yes, before is printed, but after is not printed because, let me run that again, because an exception has been generated from here, from this particular line, because we are trying to assign a value 10 to this particular array at the index of 6, but 6th index doesn't exist for this particular array because its total length is of 5. So its last index must be 4. And what Java has done it for you is it has displayed the exception type. Okay, now you can expand this complete and then it will show you the stack trace from where it has been generated, from where it has been started, to which class, which subclasses it will pass on, and you can completely pinpoint from what is the problem and from where it has been generated actually. Okay, so this is how the Java virtual machine, Java runtime environment will actually handle. Now we'll try to handle it ourselves. Okay, so what we have to do is we have to put this block, the code block which you want to monitor, that if there is an exception or not, you should put that code block inside the try block. So I will write try and put this, and I will put something like this. Okay, so this particular 3 lines of code are now inside this particular try block. So what this try block is doing is it's looking for exceptions right now, and if there is an exception, it will pick it up and throw it outside of the try block. Okay, after this try block there must be, and let me say that again, there must be a catch block. A try block cannot exist without a catch, a catch block cannot exist without a try block, and a try block without a catch block will not be there. Okay, so I will write catch and an argument box and body. Okay, now let's say I know what is happening here. This particular exception is array out of bounds exception, and let's say E. Okay, it is okay. I must have, yes, array index out of bound. I must have missed something. And let's say I will write system dot out dot println, and I will write inside the catch block. So let's try to run it this time, and wait a minute, we'll also put system dot out dot println, and I will write here out of try catch block. So what I am trying to do here is I have told you that if you are trying to handle this particular exception manually, so in that case, if there is an exception out of this try block, this catch block will caught it and will do something about it. What I have done is it will tell you this particular thing. It's not doing anything, but that is just an example. And after that, the execution of the application will resume. It will not terminate as in the previous example that we have seen. And how will I specify this? How will I, let's say, मैं कैसे पता लगाऊंगा कि ये है या नहीं है? I will try to put a line of code here after the try and catch block. If what I have said is not there, then this line must not print actually, because if Java runtime environment has caught this particular exception out of this particular code block, then it would uh, try to terminate. It will certainly terminate the execution of the application then and there, and we will never see this particular line executed. Okay, so let's try to run this. Okay, and okay, so before is there, that is before the exception has occurred. After exception has been thrown out of this, particular line, that is array out of array out of bounds, the try block has picked up that exception and its object, it has thrown the object out of the try block, which has been caught by the catch block. The catch block then executes its body. In that body have written a system.out.println let's say command, which prints to the console inside the catch block which has been there. And after that, the normal execution of the application resumes. So out of these two blocks, the only line of code is out of the system.out.println, which prints out of the try and catch block, which is also there. So same application, what we have done is instead of telling the Java runtime environment to handle the particular exception, we have handled it ourselves. And at this time, in this particular point of time, we doesn't let our application to terminate in between. Okay, so that is how you can handle these kind of exceptions without the interference of Java runtime environment. And I will stop this lecture right here, and tomorrow we'll continue with the exceptions. Thank you.